Did you feel came out of left field? Surprise? We didn't know anything about that. I never learned that.
I mean, there was the extra credit question with the light. I didn't really know.
So the fun thing with that extra credit question, it becomes a very hard question to answer if you can't answer the question before it correctly. Nobody answered the question before it correctly. So if you can't answer that, you can't answer the extra credit. So yes, you're right. It becomes a hard question to answer. That's kind of what extra credit is. I did provide that context. So one of the things with that extra credit is, do you understand what it means to absorb light? And that becomes a hard question because it's something theoretically you learned in Gen Chem. You just may not have realized it, which is why in the question itself it says electrons are excited. Okay. So yeah, within that context, it's now just interpreting the answer that you provided for the previous one. And if your answer for the previous question is shaky, then yes, you're right. Answering the extra credit becomes very challenging because you're basing it on content that you don't have. Other questions, comments? What'd you do to prepare? Study the night before. Okay, incredibly common. Almost everybody's going to do that. I understand that. I will say that strategy may have worked in almost any other class. It does not work very well with OChem. Okay, what you're attempting to do at that point is just memorize to regurgitate it onto the test. That's a phenomenal thing for a memorization-heavy class. Almost everything we do is application. Application is not something you can memorize your way out of. Okay. Some people can, okay? And I hate to be the bearer of bad news. I would bet one person, maybe in this entire room, can memorize their way out. And for the record, that is not me. Okay? And if you're like, oh, well, that must be me, you stop playing the lottery. It's a bad idea. Okay? You need to work on your application. Application requires time, which means your preparation shouldn't be the night before. Theoretically, when you were preparing for this, it was the week before because you'd already finished the practice exam and you were just figuring out why things were wrong and how you could modify and what you needed to learn to figure those things out. Okay. Considering that some answers, there was no feedback provided on the practice exam, would argue that that part was not satisfied. Okay, which is okay, that happens. Okay, we all have jobs, we all have different things going on in our lives. That definitely makes things challenging. Okay, but that does mean things start to slide. Okay. The last question is, what can I do differently?
More time.
What do you mean more time?
Less questions, more time. I don't know, I feel like some of it...
Okay, so now I understand what you're saying.
Yeah, I feel
so,
like Abraham told me that he could have solved it all and gotten it if he had more time.
okay, that's fair. Yeah, that's fair. Time is always going to be a factor, right? Regardless, right? And I can't hear enough from people, both faculty and from students. Oh, well, time shouldn't be a factor. Time shouldn't be a factor. If you go to the doctor and they're like, we can't see you for 6 months, come to us then, versus a doctor that says I can see you that day, which doctor are you going to go to? The doctor that day. Okay? Time is a factor. Time is always going to be a factor. You have to acknowledge that and you have to build from it. Okay? If you're going to move into an emergency room, you've got a person with a bullet wound, okay, that's starting to bleed out versus someone with a cough. Okay? You have to triage and decide who you're going to work with because time is a factor. If you don't fix the person bleeding out, they could bleed out and die. The person with a cough probably doesn't matter. Okay? And so time is always going to be a factor. You have to get used to that aspect behind it. And you have to learn how to triage and fix the things that you can fix. Okay? In a hospital environment, it's going to be a little bit different because you're probably being told what to fix. Okay? Probably because there's somebody else with the responsibility telling you what to do. Okay? So, but that might very well be your job. Maybe not. So when it comes to the test, what you should be doing is triaging it. You should find the things that you know, get those answers down. And maybe you did, I don't know. Okay? But those are things that you need to do so that you can spend more time on those other tougher questions.
So how did we do? You said the average was like 60 something for the last class. What was our average?
The average for the last class was not a 60 something. The average 2 years ago was a 65. The average last year was a 53, and the average this year was a 56. So a little bit of bright side, did better than last year, okay? But we're still 10% under what happened, whatever that is, 2 years ago, okay? And I didn't get time this morning to try and dig back even further, which may not be possible. They might have had a slightly different test. I'd have to actually dig back to see. Okay. But from what I can see, we're still well under what happened in the past. Okay. Is this score reasonable? It scares the living bejesus out of me. I can go with that. Okay. This content, whether you like to admit it or not, had some review. Okay. So you spent 5 weeks studying for this within this class. You also spent 2 or 3 weeks beforehand studying for this. So you spent 8 weeks on this exam. Do you know when the next exam is?
Like March 1st or March
2 weeks. So you've got 2 weeks to prepare for the next one, okay? And you don't have the benefit of it being review content. None of this new content or none of this stuff coming up is review content. It's all brand new stuff, okay? Which means we have to shift that much harder to really pick it up, okay? Which is rough. It is. Full disclosure, most students don't need the new content, okay? So it's really just going to hit one exam and then you don't have to worry about it hitting you that hard for every other exam. Exam 1, this content is going to show up again and again and again and again. It's going to show up in exam 2, it's going to show up in exam 3, it'll show up on the final, it'll show up in second semester, okay? In every single question, okay? Exam 2 content overall will probably show up in a small part in both the final and on exam 3, and it shows up depending on where you decide to take OChem 2 if you have to in each of the exams in OChem 2. Okay? Some professors push that content more heavily than others, but it does have at least a middling appearance. Okay? So what can I do differently back to the time issue? Not only do you have to triage, but in the next part, what happens if I start taking away questions? Each question now becomes worth more, which means every weakness gets exploited that much more, okay? Which I'm less a fan of, okay? Both as a student and as an instructor. Because what I think will manifest there is that we get even lower scores because you miss one question and you're out, kind of a deal. Kind of, sort of?
Yeah.
Okay. Any other suggestions? Yeah.
Listen to Mike.
No. I'll let you just decide what to do with that one. So we already kind of talked about this. So it's about 10% worse than the highest performance in the past. So one of the things that I try and do, both kind of from a science point of view and trying to improve performance, is look for differences. Content is the exact same videos, okay? Which, full disclosure, you should complain about. Like, it's the same videos for the last 3 years. Like, you should bitch about that. That's fair. Okay. The exam is the same. The only real difference that I saw within it is that there were in-class worksheets for that semester. Those worksheets tended to push students harder and further than the content itself. So most people struggled with those, and for the most part, everybody hated them. there were very few people that actually appreciated them because they're like, oh, it allowed me to see how it applied to like crazy, wicked organic synthesis, which is great. But none of you want to be synthetic chemists, and I would have argued didn't need that content. But maybe there's some value in those worksheets actually pushing you beyond your limits that's helping you to actually pick up and learn the content. Okay? So I'm considering at least bringing those back. My one kind of concern with those when looking back at the highest performances, there were a significant percentage of that highest performance in the past scored higher than we scored in this class. And within those worksheets, those were really the only people completing those. So to me, it looks like the worksheets are really benefiting the people that were already doing well. So I'm very on the fence about bringing those back as an actual assignment. But we may see those come back. The other reason why I pulled them is I deemed it as extra work. So the whole point of a flipped class is that you come to class and work on homework and get your problems solved, not get more homework. And that's what the worksheets ended up becoming, was more homework. So students were having to do even more work to be successful in the class. But maybe just more work is what's necessary. I don't know. I don't really like that idea. Yes, sir.
And maybe don't make it worth the grade.
And I can do that. It's easy, and by definition, it won't be worth a grade because we already have the syllabus where the worksheets aren't in the syllabus as far as points. So it won't come back as points. It'll just come back as something that we could use as talking points within class, and we could use as talking points within office hours as well. Any other questions, comments, concerns?
Will we be able to see our tests?
Yep, that's what I was about to do. No, you're good.
And kind of go back to time, you already said that time is of the essence.
Mm-hmm.
There's no way you'd probably give more time, right?
There's no way to give more time.
There's no way to?
We have 75 minutes. When do you want me to give you more time within the 75 minutes of the class?
Just give an extra 10.
I can't give extra 10 because we have lab button up against it. We have people that have other classes. Yeah, that starts to run into problems. Putting it online is another option. Online performance drops even lower. Yeah. Okay, even with cheating, it drops lower. I do have statistics on that if you really want to look at those. So they're,
So you have thermal
yeah.
imaging, so they can use infrared or?
Yeah, use infrared at night.
Yeah, they're detecting very low energy signatures that the human eye does not detect. That's it. So when you're using infrared and it turns it into an image, usually it's turned into something like green. Why'd they pick green?
Pretty?
Anybody know that? Don't quote me, I think I'm right though. The human eye actually sees more colors of green than any other color. So when they convert IR light into something that we can pick up, green is something we have more receptors for, so we can see more variations within it. It's better for that system.
And I was just wondering if like infrared cameras do the same thing as infrared, obviously.
They're doing similar things, yeah. Okay. Infrared cameras are looking at those light sources, and it could just be energy bouncing off of those things to generate the image. Here what we're doing is we're aiming IR light at a sample, and we're detecting what happens.
Yeah.
Does the sample absorb that IR light or not? Okay, so really this is UV vis spectroscopy. If you remember using the colorimeters in Gen Chem, does that sound vaguely familiar? Okay, that's IR. Okay, it's pretty much the same thing, except instead of using ultraviolet light or visible light, we're using infrared light. Okay, so our molecules will still respond to it. They respond to it differently. When we use ultraviolet or visible, it causes literal electron excitations. It's electrons jumping different orbitals. What orbitals? Molecular orbitals. Okay, and that's ultimately how we see color, which is a whole other thing that we can talk about next semester. When we move into IR, that's not enough energy to cause the electron to jump orbitals. What it is enough energy to do is to cause the molecule to wiggle. okay? Or said more fancily, vibrate, okay? And that's it. All we're detecting is, did the molecule vibrate when it got hit with that light? If it doesn't vibrate, it doesn't have the characteristic aspect that allows us. And what this is going back to is a rough approximation to what a bond is. A bond is two atoms connected by a spring. That's it. Okay? And if I hit that spring, it vibrates. There's multiple ways it could vibrate. We could do what I'm showing here, which is this stretching or compression aspect. We could also do a bending aspect, okay, or a bending type of vibration. Those are going to require different energies or different ways to kind of oscillate it to get it into that action. IR light is saying, what energy are we using to cause that particular vibration? And there's lots of things that affect it. If I took two bowling balls and attached them with, I don't know, let's do the shocks on a car, do you think you could get that to vibrate?
Be a lot harder.
It's going to be kind of hard to do. Right? The bowling balls are heavy. The shocks from a car are designed to deal with thousands of pounds, not tens of pounds. That's going to be really hard to cause it to vibrate. So you're going to have to put in a lot of energy to get that. That's going to show up in this system. Right? But if I picked a tennis ball and just attached it with a slinky, that's going to be really easy to vibrate. Right? Because there's not a lot of force necessary to cause it to vibrate. That's looking at the numbers along the bottom. That's about it. Right? Larger numbers means more energy. We're getting into light and Planck's law and all that fun stuff that you guys learned in Gen Chem that I don't remember very well. Right? But I believe that means more energy to cause it to vibrate. Right? Well, remember, there's multiple pieces that contribute to that. The strength of the spring and the weights of the objects on either end. Right? So what we're responsible for doing isn't for looking at something on there and going, oh, well, that's totally the carbon hydrogen from hexane versus from methane. What you're responsible for doing is effectively patterning, okay, pattern locking it, so that when I see this peak here, okay, which we'll get to in a second, 3, 1, 2, 3, at 3,300, that gives me some information. That means to me, I'm looking at the nitrogen-hydrogen stretching vibration. Do I care, or do you care that it's stretching? No, you just care that it's nitrogen-hydrogen. What does that mean to us? This spectrum, if we look at the compound that was used to make this, had a nitrogen-hydrogen bond in it. How many? I don't know. Okay? But it had at least one. Okay? Unfortunately, that same signal could also be due to an oxygen-hydrogen. Okay? There are subtle differences between the signal between those. Those subtle differences are things that you would have to pick up through experience, which is one of the things that makes spectroscopy so painful and so nice at the same time. It's painful because a lot of these observations come from experience. Okay? Do you have any experience looking at these? No. Which means it's really hard to look at. You just say, I just see a bunch of things. I don't know what to get out of it. Because you don't have the experience. Start working on that experience. Okay? This is why in the lab, the whole point of the lab is to force you to do a bunch of experience. Okay? That's going to cover kind of a baseline for you. You need more experience beyond that. This is why we have textbooks. This is why we have the internet. Okay? This is an area that students struggle with universally through OChem. You can just Google spectroscopy practice, right? And you can find tons of, or you should probably add the word organic spectroscopy practice into it. And you can find tons of different practice things to go through to figure out what's happening within it. And so if you're in that mindset of I just want to memorize, this is a decent place to just memorize your way out of. Okay? It's a lot. But it is a place that you can do it. That just means you have to have all of that background as a place to memorize. You have to do the legwork to build that up. Kind of, sort of? Okay. After that, okay, when I look at it, I'd look right about here. I'd note that that was less than 3,000. I would call that CH stretches. But Mike, there's multiple peaks. I don't care. I'm grouping them all together. That's CH. You can do that. You can, because that's the standard peak patterning that you would see for a CH. On top of which, because I know hybridization is a thing, the hybridization changes the orbitals, which means we're changing the bond strength. We're changing the spring in between. Okay? And if that carbon is sp3 hybridized, it shows up under 3,000. This one shows up under 3,000. I would call that carbon sp3 hybridized. I wouldn't call it sp2. I wouldn't call it sp, because those show up at different values. How do I know that? Experience. Okay? The rest of this, I can't quite get that dramatic yet. Okay? That says 15, 16, 17. I'd call that out. Color I need to be, let's go with blue. Showing up about 1650. Probably call it a carbon-carbon double bond. Okay? But I'm a little nervous because I also see this peak about 1475 and that one's sitting about 1500. All three of those together usually means it's a little bit more than a carbon-carbon double bond. It usually means I'm looking at a benzene ring. Those are carbon-carbon double bonds, but those carbon-carbon double bonds are different from a standard carbon-carbon double bond, because what can the carbon double bonds do in the green structure? Resonance. Is that resonance going to change where the electrons are located? Is that going to change the bond vibration? Yeah. Those things together change the frequency enough that that's likely to be a benzene. Okay? There's a whole bunch of other peaks here. Should you analyze them? We just started all of those. Why don't we go into all the others? We don't.
You said they're useless.
Did I actually say they're useless? I might have said that. That's a bit of an overstatement.
You said they're not useless, but we're not pros enough because we're dumb, so we should be going.
I like that description a little bit better. Yes. Okay? Officially, 1400 and lower is what's known as the fingerprint region. So if you were going to identify someone, you would probably reference their hair, their eye color, their height. You're not going to reference the swirls and patterns on their fingerprint because it's really hard to identify somebody based off of that. Okay? That's what's happening in this region. Okay? This is looking at the fingerprint. These signals greater than 1400 are now looking at hair color. Okay? Height of the chemical, if you will. Okay? So we tend to ignore the fingerprint. Okay? You'll note that these two peaks are not within the fingerprint. Okay? And yet still I choose to ignore them. Okay? Why do I choose to ignore them? For me, personally, I expand that fingerprint up to 1600. Okay? And it's not because there isn't useful information in that 1600 range. There is. Okay? But the odds that I'm going to screw it up start going higher. For me, 1600 and larger, the odds that I screw up the assessment, maybe 10% of the time. If I'm looking at 1600 to 1700, where did I say, 1600 to 1400, the odds that I screw that up go up to maybe 40% of the time. Okay? I don't like those odds, so I'm not going to take them. I choose not to. If I go into the fingerprint, the odds that I screw up an individual assessment jumps to probably 90% of the time. Okay? Which is why you'll get people calling them useless. Okay? There's absolutely useful information in there. It's just really hard to analyze, and it usually isn't worth the trouble. Usually. So when we're thinking about spectroscopy, what we're trying to do is look at it and find our patterns within it. Okay? What we'll end with, because I just noticed I lost track of time, when you're looking at IR spectroscopy, is it's a shape game. Okay? Which I know I've said in the videos, but I need to really get that across. Okay? What you're doing is looking at the patterns and saying, that looks like a circle, so I'm going to put the circle in the circle hole. That's how it works. Or if you've seen the video, I'm going to put it in the square hole. Okay? What you're trying to do is just match the shapes. That's it. Okay? And as such, the matching shape game is very fast. The interpretation I just put up there took us 10 minutes. That should be under 10 seconds. Okay? That's how quick your interpretation of IR needs to be. Which means, are you going to be right? Probably not. But what you're trying to do is get big picture ideas down and use those big picture ideas to continue into other forms of spectroscopy. That's where you would look at mass spec and the different forms of NMR. Okay? And you'll note all 4 of these have different characteristic signals. Okay? You're looking at different numbers. What you need to be able to do is relatively quickly look at a random thing and be like, that's mass spec. Okay? I need to use the mass spec rules to solve this. Okay? For those people in lab, we will be talking about this in depth in lab and kind of pointing where things are at and probably just turning you loose on the assignment. Okay? Yay this week. If you don't have lab, everybody has lab. Everybody has lab? Everybody has lab. Okay. If you're not in lab, go today. Not in lab today. Sorry. Leave. Oh, leave the exam on the table. Useful document can be found in the tutoring center. 1-pager that shows it all. Thank you.
I'm not gonna lie, I thought I did pretty good. He said, like, oh, you guys didn't know. I said, literally, I studied an hour before. Don't you remember that?
So you want to fix in the future then, right?
Yes. At least by height is
Day before, at least?
I don't know what I'm saying, I feel like I knew this, I was just like, it's so easy, it required more time for me to sit down, and some of them were just like simple mistakes that I was like, I can't believe I missed that.
You will find there's a high frequency of common mistakes. The difference between, I would argue, an A and a B is really nitpicky.
Yeah, it wasn't until looking this over and I was like, how did I mess this up? Like, I know what the answer is, like, I literally just got the answer, but how did I fix those other answers?
C, the difference between probably even C and B is content. The difference between A and B is almost always just how nitpicky you are with details.
I'm gonna go see if the vending machine works now. I forgot, I didn't.
I wish you luck.
Yeah, 'cause it's been broken, I don't know.